Hello. So I'm going to start the normal distribution. So in the previous video, I introduced what is a continuous random variable and what is the problem associated with continuous random variable. So we learned there is no probability for a point. So you have to think about inequality or area to define probability. So, and as a special case and as the most famous continuous random variable, we are going to study normal distribution. And actually, the normal distribution is the most important distribution in science, in any science. I think there is no debate, right? No one can argue this. Like, no one can, nobody can say this is wrong. I believe any educated person would agree with this. In natural science, a lot of things are just assumed to follow normal distribution, and normal distribution is found in the nature. Like heights and weights of animals and plants are normally distributed, approximately normally distributed. I don't know why. And velocities and the velocities of the molecules in the ideal gas, I don't know what it means. But when I search for examples of normal distribution, I just found it. That just sounds cool. And maybe in physics or chemistry, in the ideal gas, under a certain condition, molecules move like in normal distribution. Yeah, I don't know what it means. But anyhow, somehow it is normal. Also in social sciences, normal distribution is pretty commonly assumed. We just assume that, like say, test scores are normally distributed. So then we have standardized test scores. And like if we assume asset prices are normally distributed, then you can calculate the option value, which is called the Black-Scholes equation, right? If you are familiar with finance, I guess you will understand what is the option value. But if not, that is still fine. Don't worry too much about that. We don't learn what is the Black-Scholes. And also, Six Sigma, if you assume that the manufacturing errors are normally distributed, then GE researched GE in the past when GE was the best, the biggest company in the world. Their slogan was Six Sigma. So they are going to minimize the error up to Six Sigma. Later you will see what it means. Anyhow, in different fields use normal distribution in their own way, right? And not to mention statistics. They are outside of statistics. In statistics, it is even more important. The problem is, in the end, I said every random variable will be approximated to a normal distribution. That's still true. But the problem with the normal distribution is we cannot derive where it came from. I mean, it is not easy. You can do that. It has several assumptions, and you can show that under the assumptions, normal distribution is derived. But that is so much difficult, so mathematically involved. So I'm not going to describe that. Binomial distribution was really easy. We can think about online quiz as an example. Then under reasonable assumptions, we get binomial distribution. But the assumptions for normal distribution is purely mathematical. So I'm not going to explain how it is derived. But in the end, it has only two parameters. Mean is mu and variance is sigma squared. And of course, variance should be strictly positive. And the reason why we learned the mean and the variance in chapter 3 and 4 is because we need them to understand normal distribution, right? The reason why variance is widely used as a measure of variability is because normal distribution uses that as a parameter, right? So normal distribution is pretty intuitive in this sense. We write x follows normal distribution parameter mu and sigma squared. This is Greek letter mu, and this is Greek letter sigma. Sigma squared is the variance because sigma itself stands for standard deviation, So we usually take square here. And simply, instead of writing normal, I will write just n. It stands for normal distribution. I will use this. And the bell curve. This is the PDF of the normal distribution. Probability density of the normal distribution depends on the parameters. Say I fix the variance to 1 and I change the mean from 0 to 1 to -1. So -1, 0, and 1. So as you see, the mean captures the center, the peak, right? Blue is centered around 0. Green is centered around -1, which is its mean. Orange is centered around 1, which is its mean. So always the probability density of a normal distribution is centered around mu. And highest point is at the center, and it is symmetric, always. And when you fix the variance and change the mean, it's just parallel shift, right? The shape of the bell curve is captured by the sigma squared, the variance, but its location is determined by the mean. Okay. Now, when you fix the mean and change the variance, as I said, it changes the shape, how flat or how sharp the density is. So when the variance is small, 0.5, as you can see from the green density, probability is very dense at the center, at the mean, right? It's more dense, and it goes down pretty quickly as you move away from the center. But when the variance is large, like orange, which has variance of 2, it is very flat, right? The density is much lower at the center, but more dense on the tail. So it's not that dense in the middle, but it decreases pretty slowly. So the tail is longer, okay? So it's more spread out. So again, mu, the mean, determines the location, and the variance determines the shape, right? So let me describe a few more basic properties and important things about the PDF, which is called the bell curve, right? So when we say the bell curve, it usually refers to the normal distribution's probability density function, and it is always symmetric about the mean. So mean is the center, it is symmetric about that. So the skewness is 0, and so the median is the same as the mean. It is not skewed at all, right? So, and the probability is peaked at the center. Right? Highest point is always the center, the mean. So we say the mode is mu, and it is unimodal. There is only one peak. It goes up and down only once. And the range is infinity. It ranges from -infinity to +infinity. Even though the probability goes to 0 in the limit, but still it is possible. It's not exactly 0, but converges to 0, but not exactly 0. And the probability keeps going down as you move away from the mean. So that is another well-known property. And as I said, change in the mu shifts the location, and change in the variance changes the slope, the shape of the bell curve. So these are some basic things we can find from the bell curve. I believe it should be pretty straightforward. And as I said, we are going to approximate every random variable to a normal distribution. But how can you calculate the probability? I just gave you the bell curve, but how do we know the probability of this? We cannot do that by hand. We are going to use Excel, or you can use calculator. Calculator usually does not have like normal distribution, so I recommend Excel. So Excel has, of course, all the necessary functions, and easiest way to calculate the probability, but still you have to think about different parameters, right? So depending if you change the mu and sigma squared, then your probability will be different. So where we start is the simplest possible case. We will, for now, fix the mean to 0 and the variance to 1, right? So, and we call that the standard normal distribution, right? We will fix the parameter of this standard normal distribution to 0 and 1. That means we know everything. It's like the parameter is known. So we treat this as a special random variable z. Z is a standard normal distribution, which is normal distribution with mean 0, variance 1. And we are going to use the CDF method to calculate the standard normal probabilities, right? Like many years ago, as I said, we cannot handle this by hand. We cannot calculate the probability by hands. So at that time, I distributed a standard normal distribution table, like printed on papers. So it's like you have to find the probability, like finding a row and a column, and then you search for the probability, which is really outdated. So I will use Excel. Or you may, if you don't have Excel on your computer, you may just Google like standard normal distribution calculator. Then they will do the same job. So back to Excel formula. Let's search for normal. If you search for normal, there are too many search results. But what we are going to, you can see norm.dist, norm.dist. This is normal distribution. So let me just copy here. Norm.dist is returns a normal distribution CDF. And norm.inv, it returns the inverse function of normal CDF. Later we will use why we need the inverse. And what we are going to use actually is this one. It returns standard normal distribution and norm.s.inv. It returns the inverse function of a standard normal CDF. These are four main formulas we are going to use. Let's try this again. So here, right? And these are outdated functions. Yeah, standardize. Okay, so we will do many exercise using Excel, but I'm just telling you ahead. So, let's think about, let's go back to the CDF. The definition of the cumulative distribution function was like this. If you input a value A, then it returns the probability of that random variable smaller than or equal to that value A, lowercase a. So you are going to get this information, right? So now let me show you how to calculate these guys. So f minus 2, f minus 1, minus 1, f0, f1, f2. And of course, capital letter F is CDF, and I will use this function. I will use that function, so norm.s.dist, and you enter the value here. The first entry should be z, which is the value, and In the second entry, you have to choose the option whether it is cumulative distribution or density. I will choose true because we are looking for the CDF. True. Then this is the probability smaller than -2. So the probability that standard normal distribution is smaller than -2 is 2.275%. Okay? And similarly, like you may keep doing this. Less than -1 is 15%. And less than 0 is 50% because it's exactly symmetric. So less than 0 is 50%, greater than 0 is 50%. And let me keep. So you can find the CDF of standard normal distribution. So standard normal distribution smaller than -2 is this one. Smaller than -1 is this probability. Smaller than 1 is this. Smaller than 2 is this. So you can calculate at any point on Excel, right? But I will use those 5 typical values. And I found them. So then from this, we learned CDF function returns probability smaller than something, but we may use that information to calculate probability greater than something, like here. Probability greater than -1. How can you calculate that? It's based on this. We learned that probability smaller than -1 is 15.866%. So 100 minus this probability must be probability greater than -1. From Excel, like 1 minus this will be, this is probability greater than, z greater than -1. Okay, this is probability z smaller than -1, which is 15%. Now we are interested in greater than -1, then you have to take 1 minus this probability. So 84 times 84.1345% is this probability. Answer is here. Okay, so what I write is the rounded number. Okay, you know, like we learned how to calculate this. And another interesting point here is you may use the symmetry. Probability greater than -1 is this area, right? But like from the -1. But if you flip, like if you take its mirror image, you will have this. But now this starting point should be +1 because sign should flip, right? So you may calculate probability smaller than 1. That is, this guy is actually same as this guy, right? There are two different ways. You can use just smaller than -1 to calculate greater than -1, or you can use the symmetry to just calculate this probability. It's up to you, but it's totally up to you. And now let's think about probability between 2 points and between +2 and -2, +-2. And we learned that is the difference between this probability and that probability. Okay, on Excel, you calculate, say, probability greater than -2 but smaller than +2 is the greater probability minus smaller probability. It is 95.4500%. Right? So you remember what I explained in the previous video. Interval probability can be calculated by taking the difference of two CDFs, cumulative probabilities. And that is 95 point something. And this probability is approximate of 95%. So we like rule of thumb is that plus minus 2 contains 95% of the 95% of the standard normal distribution. 95% of area is in between plus minus 2. So in other words, outside of plus minus 2 is only 5%. Right? Most of the probability is 1 out of 20 is outside plus minus 2. So that is a common rule we use in the later chapters. Okay? Okay, so I will so it was pretty easy to calculate probability. And in the next video, what I'm going to do is the other way. So far what I did is I gave you A, then what is P? That was the question. But now we are going the other way. I'll give you P. If P is given, then you have to find out A, the value that gives you the given probability, right? So that is the inverse of the CDF. Like we are going to use this guy, right? So we will use the inverse function from the Excel. So see, I will do that in the next video. Thanks for watching, and see you in the next video. Bye.